Welcome to another episode of MrLopezClasses.com. Today we are going to continue in our book of air conditioning system. And this is the chapter 6. Today we are going to talk about the chillers, and we are going to talk about the pump relay systems. The chiller system. What is the meaning of the chiller system? A lot of people have a confusion about the chiller system. You remember our traditional air conditioning system? This is a split unit. You remember what is the meaning of a split unit? A split unit is the condenser located in the bilge in the engine room. That's the condenser. You remember the element part of the condenser are the compressor, the control box with the circuit board of the control box, and the raw water system to cool, to condensate the refrigerant. That's the condenser. This is the same element that you have in your home outside. Okay, that's the condenser. In our boat, that condenser is located in the bilge. And this is the typical unit of a condenser of a split unit. And in the other side, we have here we have the evaporator. The evaporator is the element that you have in the cabinet, in the closet, behind of the bed, in your boat. In your home is the element that you have inside of your home. Normally in a closet, you open the closet and you found it, that evaporator. The people call this is the indoor coil, and the condenser located outside is the outdoor coil. But both of them are communicated with the blue line and the red line. Those copper lines have a freon, have a refrigerant internally. And normally that refrigerant is covered with a special foam in order to keep the temperature of those pipes isolated from the environment. That's clear? Or depending of the distance in between the evaporator and the condenser, I have a lot of pipes, copper pipes, and we have a lot of chances for leaks, because it's possible that other contractor installing other equipment perforate that line and release the refrigerant. It's very common in marine applications that other contractors installing other type of equipments make a drill and perforate those lines. That's not good. That's the inconvenience of the split unit. You need to transport refrigerant for a long distance in between the condenser and the evaporator. For that reason, some technicians, some engineers prefer the self-contained unit like this, because that unit have the compressor and the evaporator together. No, those are self-contained unit. The compressor and the evaporator are pretty close in the same compartment. This is a good advantage. That's the inconvenience of the split units. Now we are going to introduce, using the same concept of the split unit, or similar concept, we are going to introduce the chiller unit. But we are going to check what is the advantage of the chiller unit. And now we are going to try to understand what is the meaning of the chiller unit and why every day are more popular, especially in mega yachts. In mega yacht, the majority of the new air conditioning systems are chiller systems. The same like in complex like universities or banks, where, for example, in universities they have a campus and they have one air conditioning unit located in one place and chiller handles in different buildings. We're going to check what is the advantage of that system. It's highly efficient and is easily to service. It's not difficult to repair the air handles in each building. Right now I am going to explain what is the meaning of that and how a chiller unit works. And after that, we are going to analyze the pump relay systems. Other good design in order to avoid too much raw water pumps and too much holes too much perforations in the structure, in the hull of the boat. Yes, this is another great design, another great invention of the marine engineers, and we are going to analyze both of them in details. We are going to start with the chiller system. Suppose this is the compressor, no? This is the condenser. This is the condenser located here, and we are going to transport the refrigerant. The refrigerant pass through the dryer, the expansion valve, the capillary pipe, and this is the coil of the evaporator. This is the coil of the evaporator. And after the evaporator in the output, the refrigerant return vapor, and enter again into the compressor. That's clear? Until this point, you remember this is the typical cycle of refrigeration that we have in the majority of our air conditioning system, in our home, in our car, in our boat. All right? Okay. You remember that in particular in our boat, in the evaporator, we install a blower, and the blower suction the air, the ambient air here, and in the other side you receive fresh air. With this blower, that blower is installed over there to pass the ambient air through the frozen pipes, and in the other side you receive fresh air because those pipes are too cold. Inside of those pipes, the refrigerant starts to evaporate. You remember that cycle? I explained in details that situation. Okay, but what happens if I eliminate this blower? I eliminate the blower. I have the coil. Exactly like we designed before, the coil. And the coil enter and continue with the vapor. This is the coil with the refrigerant vapor over there. But what happens if, remember, that coil is practically frozen because this is the coil of the evaporator. What happens if I introduce that coil in a container with fresh water? Let me check that. I am going to make a drawing here of a container with fresh water, and that container is full of fresh water. In other words, that coil, practically frozen, is surrounded for fresh water. Nice, no? What happened with the fresh water around that coil? What happened with the temperature of that fresh water? Yes, that temperature of the water decreased a lot. And right now I have chilled water. What happens if I transport that chilled water into a separate coils in each room, in each building, and in front of that coil I put a fan? What happened with the air in the other side of that coil with chilled water inside? The air is fresh air. And I continue with the chilled water and the chilled water enter in other radiator, and I put other fan in front of that radiator and other fresh air for other office, for other department in that company. And I continue with the chilled water, and the chilled water enter in other coil, and I put another fan in front of that coil, and this is the office of the engineer's office. And I have air, fresh air, and I can install different amount of air handles with fans, electric fans. and the air in the other side is fresh air. Yes, my friends, look at this. Suppose that this is the output, and I continue over there, and I have one coil here, and after that I continue over there, one coil here, and after that I continue over there, one coil here, and I am going to locate one fan in front. And of course, what happened with the air here? Fresh air. I am going to locate another fan over there, and what happened with the air over there is fresh air. And I am going to locate another fan here, and the air over there is fresh air. Those coils over there are air handles. Those are air handles. And the water return here, enter again into the chiller box with fresh water internally. I am going to install a pump to help with the circulation of chilled water. Chilled water pump, or pump circulating pump. And that's it. This is the chiller system. In other words, I have one traditional air conditioned system located in one place of the campus, for example, and the evaporator is located inside of a box with fresh water. And that fresh water circulates outside of the building in different handles and return into the box with fresh water. This is the chiller system. For example, suppose that this is, for example, a bank, and this is the chiller system for accounting, and this is this is the air handle for the financial office, and this is the air handle for I don't know, for the bank, the office of the bank, different office. Oh, I have a problem in the accounting office. I isolate, I disconnect the valves. They install valves here. They install valves over there. They close the valve, remove the equipment, replace the equipment. They don't need disconnect refrigerant. They don't need recover refrigerant. They don't need added refrigerant, because in those lines you have a chilled water. I have a leak of water. No problem. I clean, I dry the area, and I added more water here, more fresh water over there in the tank, and I keep the tank full of water. Finito. This is the chiller system. In a boat, it's very, very common. We have the chiller system located in the bottom, and we have the unit on top, like this.
We are going to analyze in this chiller system how the thermal expansion valve works. This is the output of the compressor. This is the high pressure. This is the high pressure liquid. This is the side glass, and this is the liquid high pressure, high temperature, and this is the expansion valve. The expansion valve open and close depending of the signal coming from this capillary pipe that finishes in this bulb. This bulb is located at the output of the evaporator. This is the output of the evaporator, and here is located the bulb. The bulb sends the temperature of this pipe, and according with the temperature of this pipe, send the signal to the thermal expansion valve, and the thermal expansion valve open and allow that the fluid pass through the venturi and produce the reduction in pressure and temperature, and goes down here with low pressure and low temperature and enter in the bottom of this evaporator practically frozen, and continue frozen over there and return here. This container internally is surrounded for fresh water, and this is the fresh water that continue in different radiators, and the radiators have fans in front. That's the chilled water that is used for different fans. That the output of chilled water, and this is the return of chilled water. Internally in this box we have fresh water, chilled water. Once again, this is the refrigerant with high pressure and high temperature, and this is the thermal expansion valve. The thermal expansion valve operates with the diaphragm internally open and closed depending on the signal. The signal is coming from this small capillary pipe connected to this bulb. Internally in this bulb, they have a substance similar to mercury. According with the temperature of this, the mercury expand or retract. Depending how much expand or retract, the diaphragm move back or forward and open and close, and allow that the refrigerant pass through the venturi. Immediately the refrigerant pass through the venturi, the pressure and the temperature drops dramatically in this pipe, and in this moment is practically frozen, and the refrigerant frozen internally. The pipe is frozen pipe, and the refrigerant continue here, evaporated right now, and enter once again in the compressor to start the cycle again. The compressor compress the refrigerant and send the refrigerant with high pressure. The refrigerant pass through the accumulator. The refrigerant right now is liquid with high pressure and high temperature, and pass through the expansion valve. The expansion valve open and close depending on the signal. The signal is coming from this bulb, and this bulb is touching the pipe, the external pipe, with refrigerant internally. Okay, the refrigerant internally is coming from this serpentine internally. The serpentine in the bottom have a frozen pipes, and the pipes surrounded by fresh water evaporate, and the refrigerant right now is evaporated, and the refrigerant enter again in the compressor. This is the cycle we are going to repeat. This is the compressor high pressure in this point, high pressure and high temperature, vapor supersaturated. The vapor supersaturated goes down, enter into the accumulator, and in the accumulator right now is liquid, high pressure and high temperature. This is the thermal expansion valve. The thermal expansion valve receives the signal from this capillary pipe, and this capillary pipe is connected with a bulb, and the bulb is touching this pipe. This pipe is the return, the output of the evaporator. When the expansion valve open, in the bottom goes the refrigerant right now. The pressure and the temperature reduced dramatically and froze this pipe. This pipe is protected with insulation because it's frozen, and that frozen pipe enter in the bottom and pass here and start to evaporate the refrigerant. And right now here in this point the refrigerant is evaporated, but it's too cold, of course. It's evaporated and continue evaporated, vapor, and enter in the compressor, and the cycle start again and again. In this boat we have a chiller system. In this particular case, this is the raw water pump. This is the strainer. The strainer is communicated in the bottom. The strainer is communicated in the bottom with the a.c.r. That's the strainer, and the strainer pass over there, and this is the raw water pump. And the raw water enter, and those are the compressors. Those are 4 compressors. The raw water cool the compressors, cool the coil of the compressors, And after that, the raw water goes outside in the back of this wall. Behind of those compressors is the evaporator, and the evaporator cools the chilled water, and the chilled water, those are the pumps for chilled water. This is the main pump, main chilled water pump, and this one is the backup chilled water pump. And this is the chilled water that goes up into the air handle, and each air handle have a fan in front. In this example, we have an air handle. This is the air handle. This is the flow of fresh water. The fresh water enter over there, enter in the bottom, circulate through the coil, and return. And this is the return of fresh water. That's the input, pass through the coil, and return over there. The air filter is located here, is located over there. And that coil with the chilled water have the fan, the electric fan in front. The electric fan receives the signal, from the control box of the air handle. As you can see, this is an air handle, yeah, for 240 volts. This the motor of the blower works with 50 Hz or 60 Hz. This is a dual function in order to connect into both with American power or electrical power. Okay, this is the typical air handle for a unit, for example, for the master room. Okay, the flow of fresh water over there, enter in the bottom, the coil, and this is the return of fresh water. And of course, the control box, this handle is activated from the thermostat. When you select the temperature appropriate, the circuit board in the control box sends the signal, and the fan, the electric fan, 230 volts start, and suction the ambient air from here. The filter is located here, and send the air, cold air over there at low temperature. This is the typical air handle for the main saloon, air handle for the master room, air handle for a fly bridge, and air handle for guest rooms. This is a perfect chiller system. That's the raw water pump. This is the sea strainer, only to cool the compressors. Only to cool the compressors. In the back of this unit are located the evaporator, and the evaporator reduces the temperature of the chilled water, and the chilled water enters inside into the air handles, and the air handles refrigerate the rooms, the different rooms.
Yes, this is a typical chiller system in a mega yacht 120 feet. In that moment, that chiller system is in service. Danny Ramirez, one of my former students, he's the second engineer in that boat, and he disconnect the traditional raw water system and connect the cooling tower. Because the boat is out of the water, and he connect the cooling tower over there. Remember that to connect the cooling tower is too simple, because the condenser in this traditional chiller system is working in the traditional way. The condenser, the coil of the condenser is cooled by raw water. Let me check that one. The condenser is cooled by raw water. The raw water enter over there. The raw water continue, pass through the strainer, pass through the raw water pump, and enter, pass through the coil, and goes out, and bye-bye. This is the raw water that normally you see going out when the air condition equipment is running. I need disconnect that raw water system and connect my cooling tower. It's simple. I disconnect the input of this line here. I am going to connect the cooling tower here. Let me explain. It's too simple. Okay, the cooling tower right now supply water supply water here, directly here. I disconnect that point, and I connect the return of fresh water here. I have a fan on top, and right now my cooling tower replace the raw water, and the system is working with the cooling tower with fresh water. Like this, I have an stand in the laboratory, and I connect the cooling tower in this way.
And this is the water-cooled condenser. This is the typical condenser that we have in marine applications. In order to simulate the marine application, we are going to use the cooling tower. This is the connection of the cooling tower. Look, we have the high pressure lines coming from the compressor. The high pressure enter in the coil internally. Remember that it's a small pipe surrounded for a big pipe, and here the pipe is going out, and this is the pipe that continue and pass through the expansion valves and enter into the evaporator. Okay, we have two air cooled condensers and raw water cooled condenser. The raw water is coming from the cooling tower. The cooling tower receives water, municipal water, in the pool in the bottom, and the water is pumped up, and a fan on top. When the water reaches the top, the water drops by gravity, and the fan cools the water, and the water goes down by gravity, and the water is cooled. This is the raw water pump, similar to the raw water pump used in marine application. The raw water suctions the water in the middle and send the water with high pressure, and the water enters into the coil, and the water returns and enter again into the tower, and the cycle continue and continue. The cooling tower is another important equipment used when you have the boat outside of the water in the marina for service. The cooling tower simulates the salt water on the sea. In other words, we are going to replace the movement of the salt water through the compressors with this cooling tower. The cooling tower is salt water entering, is moving on top the fan cool the water, and the water drops for gravity and return into the boat. This is the pump that circulates the fresh water from the tower into the boat and return in the tower. And this is the input. This is the supply of water into the boat, and this is the return. And this is the supply. The supply continues over there, and the return to the small hose. And internally is connected according with the picture that you have on the screen. This cooling tower, the cooling tower normally is 240 double phase, and is connected to the shore power of the marina. In the marina is connected with the shore power and supply the water in order to keep the air conditioning equipment inside of the boat working during the process of reparation of the boat. In this case, the crew is living on the boat and is using the air conditioning equipment. For that reason, the cooling tower is necessary, it's mandatory.
Correct. This is the procedure to connect the cooling tower in order to do the service on that system. In other words, the condenser is working with the traditional raw water system. All right? That's the same, no problem. But the evaporator right now is not with a fan. Right now, the evaporator is located inside of a heat exchanger, but that heat exchanger is full of fresh water, and the fresh water enters in that heat exchanger and goes out. The movement of that water is by means of this chiller fresh water pump or circulating pump. And after that, each department, each office have an air handle. Is a coil with fresh water inside and a fan in front of the coil. Simple. Loose, the air handle, loose exactly like the typical evaporator, like this. But internally in the pipes, you don't have a refrigerant, you have chilled water. All right? Okay. Questions? Oh, a chiller system is an air conditioned system that don't use refrigerant, use water, fresh water. No, my friend, no. It's an air conditioned system. Look, compressor, evaporator, and refrigerant. But is like a self-contained. And you have one heat exchanger with raw water for the condenser, and other heat exchanger with fresh water for the evaporator. That fresh water goes out and enter in different small radiators, small coils, small air handles. Each air handle is located in one office, in one room. And continue, 6 air handles and return. Okay. in between the evaporator located inside of the box with fresh water and each air handle, you only have fresh water. You have a fresh water here, you have a fresh water here. All of this is fresh water. The movement between this point and this point is fresh water. Okay. But the air conditioning equipment is a traditional air conditioning equipment. The only difference is that the evaporator right now is working with the fresh water around the coil of the evaporator. That's the only difference. And this is the chiller system. It's great. It's wonderful. There are a big chiller systems with a big towers like this. A lot of buildings, banks, financial offices, they use chiller system because they administrate only one air conditioning system, one air conditioning unit, and different air handles with fresh water, with chilled water in each one. All right. Normally, in industrial application and also in marine application, they don't use fresh water. They use coolant, similar to the coolant used in the radiator of your car. You remember what is the composition of that coolant? You remember in our course of diesel and gas is glycol. It's 50-50. You remember 50% of glycol and 50% of water. And you remember what is the advantage of that system? Yes, one of the advantages is that the freezing point will be lower, and the boiling point a little higher. This is good because you avoid that the water become ice easily. For that reason, the people prefer use instead of fresh water, use coolant. But the coolant is not expensive; it's too cheap. I have a leak of coolant. Oh yeah, you added coolant in this container. Right now, in this container, you have coolant. It's water plus glycol. Oh, can I recover with pure water? Yes, no problem. Yes, this is not expensive. Oh, but it's green. The leak is green. And the refrigerant is also green, but this is not refrigerant, it's coolant. Because it's in the air handle. Be careful with that. All right? Yes. In the air handles, the majority of the equipments, they don't use fresh water, traditional fresh water. They use coolant. What is the purpose of the coolant? It is because the freezing point is lower and the boiling point is higher. In this particular case, for that purpose, we are focused in the freezing point, in the lower point. Okay. Yes, this is the liquid used in the air handles in the chiller systems. It's a glycol with water. And this is the operation of the air conditioning system. New elements that we introduce in this system, we introduce the freshwater circulating pump, and we introduce the air handles. The air handles have a fan in front of each air handle. but it's exactly the same, no difference, but the system is practically the same. The chilled water pass through each air handle, and the chilled water is the blue one, is that one, chilled water enter in each handle and return the red one, the red one into the unit. And we have a one manifold to return the red one, and other manifold, the blue one, for the discharge. The discharge is chilled water, practically frozen, and the return is warm water. And once again, enter in the container, in the reservoir, where the coil of the evaporator is located, and once again that water is chilled water and goes out again and enter in each handle. This is a good picture. Look at this. This is the condenser. That's the condenser. And this is the coil of the evaporator. That's the coil that is practically frozen, and that coil is inside of this container full of fresh water. And that fresh water, the level of that fresh water is coming from the municipal water. And that fresh water goes out, chilled water, and the circulating pump circulate the water for other units, like this. This is the unit. In this unit we have the condenser and the evaporator together. It's a self-contained unit, and the evaporator is inside of that rectangular in stainless steel, like in the previous video. And the chilled water, look, the chilled water, this is the low temperature chilled water. This is chilled, and this is the return warm water, and this is the circulating pump for fresh water. And the condenser, they have another pump, raw water pump, to keep the temperature of the condenser low and produce the condensation of the refrigerant. This unit is a self-contained unit, but the heat exchanger for the evaporator is a heat exchanger with fresh water. And those are the air handles. One air handle here and other air handle over there. Each air handle have your own thermostat, the traditional thermostat. And each thermostat is in each office. In each office, the people administrate the temperature of that office and start or stop the thermostat, increase or decrease the speed of the fan, and receive more air, more fresh air or less fresh air. And that's it. And internally in this coil, in the air handle, in that coil, you have chilled water. You don't have refrigerant. And the chilled water enter the blue one and return the brown water. The brown water is warm water, enter again into the chilled container and return again. This is a wonderful system. This is a wonderful system. This is the condenser, and this is the evaporator, and this is the warm water, and this is a chilled water. This is the chiller system. A typical chiller uses the process of refrigeration to chill water in a chiller container, in a chiller barrel. This water is pumped out, chilled water, through the pipes into the building and pass through the coils. The coils are air handles in each compartment. Air handles. The air is passed over this coil, and the heat exchange process takes place in that air handle. The heat in the air is absorbed into the coil and then into the water. For that reason, the water returns into the barrel with the fresh water warm and goes out again chilled. Simple. This is the process of refrigeration with a chiller system. Look, in this particular case, we have 3 air handles with 3 thermostats. And this is the container where the self-contained unit is located. Half of this is the condenser and half of this is the evaporator. And this is the circulating pump. This is the circulating pump for freshwater system. Remember, in the chiller system we have two pumps. One pump to circulate the chilled water, and other pump to circulate the raw water pump for the condenser. The chilled water normally is fresh water plus glycol, 50-50. The same coolant that you use in your car. And in each air handle you have one thermostat. The thermostat to administrate that handle. Alright? You like it? This is a wonderful system, the chiller system.